discuss in that section, and then we'll move into the composites. So where different types of the composite, what are the classification, where the applications of those composite material. So this presentation or webinar is basically focused on the basic things. I will not go into the detail of research, uh, where we want to go. If you understand these things, that will be very helpful and for your further thinking and your future goal also. So because of that reason, I am not presenting the research here. I am just presenting the future, means basic knowledge about the advanced materials. Because the research part, I am assuming that it will not easy to understand, because whatever I did, that research, you are in this level, you will not able to understand. So basic understanding, if you will have, then you can also propose in your final year project or in masters, or if you are thinking about the higher studies, then these basic knowledge is very helpful for you. So because of that reason, this whole webinar or whole topic, I have decided about the basics of the advanced composite materials. So what actually different firms, what they are according to the environment is also play a very important role. We are basically moving nowadays in the sustainability aspect or green environment, that you can say. So our target up to whatever the goal we have set in 2000, then according to the 2000, what is the vision in present? Our vision was set in 2000, is that we can reduce the consumption, fuel consumption of the aircraft, and also we can reduce uh, CO2 emission, because environment is polluted. If we can, more CO2 will be go in the environment. So that was the vision which set in 2020, and according to, as per comparison with 2020, we are in the position to at least reduce the fuel consumption and CO2 emission by 50%. So every 20 year we have set the goal, and according to the goal we have work on it to achieve that particular goal. Like in BTech also, you have when you enter in mechanical engineering, you have some goal. Either you want to go in higher study, or you want to go in core companies, or whatever the goal you have set it. How much you have achieved after final year, that is up to you. How you analyze yourself when you sit alone and then analyze yourself, how much percentage you have achieved. So it will not like that whatever the goal you have set it 100% you can achieve. At least you can achieve, if you have achieved 50 to 60% also, that is also very good achievement. And also the goal, whatever the set in which we achieved, the reduction of NOx also. Nitrogen oxide is also polluted the environment. And also now previous year aircraft and nowadays aircraft, at least we have reduced 50% noise. Previous aircraft you can't listen, and that was very noisy. Nowadays at least we have reduced 50% noise also. And also we can think of about the environmental effect. Sustainability development of goals, these are set by the environmental department of that is a society in the world, which 18 sustainability development of goal SDG they set, and according to that they just want to work. And also safety point of view, as comparison to the earlier aircraft, nowadays we can reduce the 80% accident. Very few accident you have listened, but earlier days it was the very huge number. And also we are using some modern manufacturing techniques, so that we can achieve the more precise component accuracy. We can achieve the accuracy, precision, reliability. So we can reduce the human error also by utilizing of the modern manufacturing techniques. So these are the vision up till 2020, and we have achieved this much amount. So when we talk about the emission reduction, we can talk about also increase safety point of view, and finally we are also need to reduce the final cost, manufacturing cost. Like if you want to increase the safety or you want to improve the emission resistance, then you can't increase the cost. So how you can cope up with all these three aspects with a minimal cost? That's why the operation research and the subject you are studying, that how you can reduce the cost of that particular any object or any assignment. So there are transportation problem, or you have studied about the CPM part. So these are the basic analysis, and also we are forecasting. So we are forecast the material for further 5 years or 10 years. How much is the cost, improve and other things. So that is also very important task. How you can reduce the cost. We can't increase the cost for aircraft working fabrication. So, how you can reduce the overall fuel consumption? You can reduce the weight. That is the one aspect, and you can reduction in the uh, part seat drag. You can reduce the drag also. So in that way, how you can reduce the weight reduction? So weight reduction, if you want to work, then you want to work on the design aspect. You want to work on the material aspect. So proper design and proper selection of material can surely reduce the weight, and that widely impact on the fuel consumption. If your weight is less, then fuel will also consume less, because that load is also applying on the piston cylinder. So like in IC engine, if your load is more, then it will consume more fuel. So you can see also the when you ride a single your person ride one by a two-wheeler, then the average is totally different. And if you can sit 3 to 4 person, and then you can see how much the fuel is burning. So these are the real examples. So in that way, the payload is very important in aerospace industry. So you can design it, develop it, and strong material select it. So manufacturing technologies are also very important. So modern finishing process, modern machining process. So these are the modern manufacturing technologies are used, or advanced manufacturing technologies. You can say very important. The computer-aided manufacturing or computer-aided design subject in to analyze these type of the design and manufacturing. And also we can take about the material. So that is the material science is very important aspect in that particular selection of the material. So, like aviation industries, what they have decided from 2005 to 2050, that they set the goal, like how much we want to improve. So like you can see here that we analyze the per year and international aviation of fuel burn. So we are targeting at least reduce the fuel consumption in that particular era. So this called the blue line, blue solid line. It is a baseline which is fleet renewal, and this green dash. This is a contribution of technologies improvement. How much technologies you have contributed to develop the material, develop the design, develop the manufacturing process. That is also play an important role, and contribution of the improved ATM and infrastructure used. So advanced technology, that is ATM. So advanced technology method and infrastructure which are using. So that is the very solid line. And dash line is the fuel 2% fuel efficiency as measure goal. So that is we are not targeting very high, but this achieving of the 2% fuel efficiency, it is a very huge task. How you can achieve this 2%? That the number is very low, but this is not an easy task to achieve at least 2%. So now previous aviation industry, the fuel consumption is more, but slowly we are introducing the composite material in the aviation, and then we have reduced the consumption of the fuel. And when we increase something, then it is something about we are targeting is the 2% per year fuel. So that is basic phenomena and environmental trend in the aviation from this 2005 to 2050. Then another is how much the CO2 emission we are working on that. So this is the basic gap into 2040 or 2050. At least we can reduce the CO2 emissions. So range of CO2 in that particular era is that dash line. So that is up till we are achieving here. So we are targeting to at least cope up with the same. So how we can calculate the CO2 emission is it is calculated by 3.16 into the fuel. So how much fuel is combust in that particular engine? So that gives you the uh, CO2 emissions calculation. So minimum gap of the CO2 emissions is required. So in that particularly we can calculate according to that, and we are targeting in this range. So reduce the CO2 emission further. So NOx emission is also like the same trend. We want to reduce it up till 2040. So this is an international aircraft full flight NOx. So we are going to also think about that one. So what is the flight path or objectives and mission and vision? Because each industry, in the international aviation industry, have its mission and vision, and to achieve those mission and vision, they have set the environmental goal, they have set the safety goals. So what they have achieved is the 75% reduction in the CO2 per passenger kilometer and 90% reduction of the NOx. So noise pollution is also further reduced by 65%, and aircraft movement are emission free when taxiing. So we are also, because when you are taxiing the aircraft means to up to runway, so the more fuel will burn. So in that range, what they will do, they just use the cart and that can pull that aircraft up to the runway. So they are also adopting in some airport. So at least they can move the aircraft from and this track to up to runway, so that you can consume or you can reduce the consumption of the fuel. Because running of this taxiing to that runway, it is approximately it will burn 30 to 40 liter fuel in that just few 5 minutes or 6 minutes. So air vehicles are designed and manufactured to be recyclable, so that you can improve the environment. Also, all the component you just made it after damaging or after means discard, you can recycle those component and again reused in design purpose. So Europe is established as a center of excellence on sustainable alternative fuels. So these are the fuel means objective which set by the International Aviation Industries or International Aviation Association. Safety goals also we are more serious about that one, because if something is happened, then whatever the number of passengers inside the aircraft, it all may die. So we have set the goal less than one accident per 10 million commercial aircraft flight. So we are setting the goal like we have more safety will provided in the aircraft. Weather and other hazards from the environment are precisely evaluated and risks are properly mitigated. Like if bad weather, when your flight is there, mm, if you have a chance to sit in the flight and bad weather is there, then your flight is very shaking. So these type of the situation, if weather is also not good, then also it will fly smoothly. So these are the some safety goals. So if you weather is not good, sometimes you also feel a huge jerk in that inside the compartment. So air vehicle are resilient by the design to current and predicted on board and on the ground security threat evaluation, and internally and externally to the aircraft. So that is also when it goes takeoff or landing time. Landing time is more dangerous other than the takeoff time. So that is very important. The safety aspects, how you can manage to develop such kinds of the material which can the more means more wear resistance and improve the life. So these are the goals set by the International Association till 2050. So you can see development of aero structure relies on the development of new materials with improved specific properties. That is also very important to improve the properties like wear resistance property, corrosion resistance property. Lighter weight should be lighter weight. That is very important. So if weight is light, then fuel consumption you can reduce it, and also you can develop some kinds of the very precise manufacturing process so that you can design that particular nature. So you can see that the specific goal like strength to weight ratio, you can increase it, reduce the cost, and it should be environmental friendliness. So that is very important. So this is the picture just taken by the internet, and you can see that the structure by nature beautifully on the leaf of this. You can see there's some kinds of the flight structure. So nature is whatever we are learning from the nature. That is the best source of the learning. So when the aeronautical material about we are not talking about the aeronautical material. So how this aeronautical material is developed since beginning, that is very important. So Wright brothers, you have heard about that, and also you have studied in the Wright brothers in 1940 1904 1904. They in Ohio, USA. They have made first aircraft, and that aircraft consists the completely wood, 100% wood, and covering the fabric. So they cover the fabric and they just make the first aircraft. So first material which is used in that aeronautical material, and that is a wood. So 100% wood at that time we are using uh, in aircraft. Further, because wood is not that much sustainable, so in the case of First World War, so we are further making and we replace the wood, and we just use the steel so that it can be temperature resistance and other benefits in that particular steel. So this is the Junker aircraft, and in this aircraft we have used the 100% steel. So wood is replaced now. Steel is came into the picture. Further, steel is also not good. That research happened, and this Second World War we are using some because steel is very heavy. So further, this steel is replaced by the 100% beryllium. So that is also material which is at least lighter than that steel. So now steel is replaced by the beryllium. Still the weight is more. Further, beryllium is also very heavy, but after that, Second World War is completed, then we are more focusing on the aluminum alloys because aluminum is very lightweight. So then we are shifting from the 100% aluminum in that structure of the aircraft. So You can see very beautifully that 100% wood, then 100% steel, then 100% uranium. Now we are moving into the 100% aluminum. So this is the evaluation of the material in aeronautical industries. So you can see here that accident in aircraft combat evaluation, and this in 1953. Canadian Pacific Airlines crashed during the takeoff at Karachi, Pakistan, and this design, whatever the earlier was there. So due to that design flaws, that accident happened. So on 10 January and 8 April 1954 led the grounding of the entire combat fleet, and after design modifications were implemented, so combat service resumed in 1958. So the huge human loss, life loss in that particular in 1953, we have found that huge loss of the human. So because of the design flaw. So in that particular case, we just resume these type of the flight, and then we work on the design aspect. And after 5 years, we resume the aeronautical services after modified design. But we are still using the aluminum. Now further Airbus 300 came into the picture, and that time we can reduce the metal like aluminum. So we are using the aluminum, but light because of the lighter weight. But we have added at least some percentage of the composite in that particular Airbus. So in this 96% aluminum we are using, but 4% we have used the composite material. So this is the era after 1960. Little bit we are adding the composite material. So further air lightweight. Now Airbus A320, you have heard about that. Indigo is having, this is the old Indian Airbus A320. They are also nowadays banned by the government because of the huge accidents happen with some designs. So in this Airbus A320, we are using aluminum 68%. So you can see that the 96% we are just come into that 68%, 6%, 9%, and this composite here we are using the 4%. Now we are using the 15% and 2% material we are using, like to improve the corrosion resistance or other material wear resistance. So we can add some element in that particular fabrication of the material. So now further 15% composite material is improved in Airbus A320. So further Airbus 380 to 800, whatever the series nowadays it is going on, we are using 22% composite and aluminum 61%. So it is more lighter than the previous era. And further, what type of the composite we are using? The GFRP we are using, that is a glass fiber reinforcement composite, quartz fiber reinforcement composite, carbon fiber reinforcement composite, and metal and glare. So metal, you have seen that these wings are made up by the aluminum, and this body is made up by the aluminum, and others we are fabricating by the carbon fiber reinforcement material. Quartz fiber, it is used in the fuselage, this main portion, and glass fiber, it is used in this tail. So in this particular aeronautical material, you can see that these are the leading edge and nose, and this is the vertical stabilizer through which you can stabilize the composite, landing gears, and aluminum, which is aluminum alloy we are using in this particular body, and this carbon fiber GFRP and AFRP we are using in this jet engine and stabilizer, and titanium and steel, it is very much very lightly we are using. So landing gears generally we made up by the steel engine and pylons is the steel and titanium, because this hinge of this jet engine, it is very important. It should be very strong. So we are using the titanium and steel, and titanium is consisting the high temperature. It will not easily burn. It is melting point is 500 above. So movable part is mostly made of the composite, and not non-movable part we just make by the metallic. So movable part, you can see that these things comes nose or leading edge or flap at the time of takeoff, at the time of the land. You can see clearly observe that they can move. So movable part we just making by the composite material. So Airbus A350 composite location is 52% composite we are using, and then other materials. So you can see the importance of the composite material nowadays is very big. So we are just focused converting into the more less material. So which is metal is 96%, 4% composite. Nowadays, metal is very less, and in comparison to the composite, you can see 52% composite we are nowadays we are using to improve the strength to weight ratio and further other properties. And also we want to reduce the uh, basic fuel consumption. So this whole body, previously you have seen that the aluminum was used, but nowadays we are just focusing on the composite material. So whole body we are making the composite, and steel or titanium we are using. Like in jet engine, this body is made up by the steel, but this steel is hinged by this titanium. So if some fire hazards or some accident will happen, it will not easily fall down because titanium temperature is very high. So this is the body structure of Airbus 787. So nowadays Airbus 787 is going on. So it is running in the airport. So 787, 777. So in these type of the aircraft, these are very safe, lightweight, less fuel consumption as comparison to the earlier, and very less consumption of the metal. So this composite can be easily degradable. It will not harm the environment. But our goal is furthermore. So this is the basic structure of the Boeing 777. So where the fiberglass is used, and this toughened carbon fiber and hybrid composite we are using in this particular one. So this is the basic another view of this particular Airbus. So what are the material we are using? Generally we use in this type of the Airbus, as I earlier told, that 60% by weight we can use the composite material, or 80% by volume we can use the composite material to fabricate this Airbus. So weight reduction, it is very, very important to reduce the consumption of the fuel. So latest development in the aerospace industries use the specific application, specific material. So in this Airbus, 61% lowest percentage of the aluminum, and 20 different alloys and tempered component we are utilizing in the Airbus 320 and 330. And new material we have added glare for the fuselage skin. So these are the just some development happen. So commercial aircraft industries, you can see that initially very less composite we are using, but nowadays we are just using the 50 to 70% composite material, and our target is to use the 70 to 80% composite material in up till 2030. So that is the target of aviation industry. So composite is very, very important, and it will reduce the weight, and it can be easily recyclable, so environmental friendly and other application. But we need to research. So what temperature and other things, temperature, thermal stability of the composite, that is also very important. How much temperature they can sustain, and after that they will degrade. So that is very important. So what is the current scenario? And by this graph, you can clearly see that in x-axis we have plotted about the specific strength and specific stiffness. So strength and stiffness of the material, it is very important mechanical properties of any material, like previous either metal or fiber. So we are now in this situation, like biodegradable composites, or you can heard about the biocomposite. So biocomposite is easily degradable in the environment, it will not harm. So that fulfill the sustainability goal. But our near future, but sometimes what happens, this biodegradable composite is also not that much thermal stable. So our future is we just move to in this future we just add some types of the hybrid reinforcement, and we can make more wear resistance, more corrosion resistance. So this is the basic future of this circle is the basic future of the material, where we can go for the mix with the glass fiber or polypropylene fiber, nylon fiber. We can mix 2 or 3 reinforcement, that is called a hybrid polymer, hybrid composite. So we just add Kevlar, aramide, and mix with the carbon fiber and other composite. So what is the strength? So nowadays the current research is going on the hybrid composite. So that is the one question comes in our mind. What is the composite material? So it is the mixture of 2 or more distinct material which can produce the synergistic property. So maybe matrix is having some property, reinforcement is having some property, but when you mix together, then it will give you the very is property which is different from their parent material, and that property is much better than their parent material. So that is known as a composite material. So another question in your mind, it will come like alloys also. We are mixing 2 or 3 element and we make the alloy. Composite also we are mixing 2 or more element or material, then that is known as a composite. Then what is the basic difference between alloys and composite? So in the basic difference between alloys and composite, you can easily identify. When we talk about the alloy, that is a homogeneous material or homogeneous structure. So each when you cut the material, each slice is the same type of same density. But in case of the composite material, it is a heterogeneous mixture. And when you cut into the slice and you want to observe the density, then each slice is having that different density or different property. So that is the basic difference between alloys and composite. So composite gives you the one direction. In one direction, it is good, gives you the very excellent property, and maybe in another direction, it will not give the good property. So that is a composite material. So it is a means property which is in going into the one direction, or means orientation of the reinforcement also play an important role. So several research is going on. So this is the basic difference. Remember it, difference between the alloys and composite. That will be helpful for your interview also. So alloy is the homogeneous mixture and composite is the heterogeneous mixture. And how you can identify, you can just calculate the density. If you if somebody give you the material and they just tell that how you identify this is the alloy or composite, then easily you can identify with the density calculation. Then you can see that the in alloy each slice gives you the same density, but in a composite it will give the different density. So this is the composite material where we have the short fiber or long fiber and we just mix with the epoxy matrix. So composite gives you the means matrix is the function which can support the reinforcement, and reinforcement is means used to hold the proper means load. Whatever the load applied on the composite, they can support the matrix. by holding the load. So advantage of the composite, like it gives you the high strength to weight ratio, high stiffness to weight ratio, so that you can save the weight, and finally it will not it will reduce the consumption of the fuel. And also our main aim was the good surface finish, less wastage, reduce the manufacturing cost also compared to other material. That was also another good things in composite material. And you can tailor the material property by adding the different types of the filler inside the composite material. So types of the fiber resin, what is the proportion you are adding, direction of the layer material, or reinforcement. In that way you can tailor make the properties. And the composite gives you the good fatigue properties, good thermal stability, and also it will be very helpful for your thermal and acoustic insulation. So that because of that reason, composite is nowadays widely used in aviation industries, and target is 70 to 80% composite. Very less metal will be used. But the problem in that particular composite, it is an isotropic behavior. Like it only gives you the good behavior in one direction, not in all direction. Isotropic material and anisotropic material. When isotropic means your property is same in all the direction, but anisotropic property, it is same in one direction, not in all direction. And that's why it is a heterogeneous mixture, and isotropic material is having the homogeneous mixture. And the composite is also very sensitive to humidity, and it will vary if humidity will vary. And stress concentration and test method is also not fully mature, means it is not complete test method is developed in the composite. Still research is going on, and we are developing as per our requirement the different methods of the testing of the composite material. So when we talk about the composites, then it can be classified by basic two groups. Either we can classify it by the matrix, what are the matrix type, and all another way we are classified by the reinforcement type. So when we talk about the matrix type, then there are three types of the composite material: polymer matrix, metal matrix, or ceramic matrix. So matrix is nothing but if matrix is having the more concentration or more way means proportion as comparison to the reinforcement. So if the composite consists of polymer in more amount, then it is known as a polymer matrix composite. If metal is there, then it is known as a metal matrix, or ceramic is there, then it is known as a ceramic matrix. And reinforcement is like whisker type. Whisker is nothing but it is kinds of the triangular shape structure. Particle type, either you are using the nanoparticle or micro particle, macro particle. Fiber types, like you are using the continuous fiber, short fiber, or hybrid fiber. So in continuous, unidirectional, bidirectional, aligned, random, oblique, or orthogonal. The structure, which type of the structure you are making, laminate structure or sandwich structure. So when we talk about the polymer, there are two types of the polymer: thermosets polymer and thermoplastic polymer. So these are the thermosets polymer, and epoxy and phenolic. These are the two thermosets which are widely used in fabrication of the polymer matrix composite. And these are thermoplastics composite materials. So these thermoplastics is widely used in that your homemade applications like bucket, mug, or different thing. And so these composite can be manufactured in that injection molding machine. You can mix the thermoplastics with reinforcement or particles to improve the strength and quality of your mug or bucket or tub, whatever you are using. Metal matrix like aluminum, copper, nickel, titanium, these are used metal matrix composite. So brake material are widely fabricated by the metal matrix composite. Further, thermosets phenolic resin is also used to fabricate the brake material. Ceramic mattress composite that use the basically glass or cement, like it is cement, you have seen that in your household application, or civil engineering, like basically use the ceramic type of the composite material. And these are the reinforcement which mix in any of three. So if you can mix these whisker type reinforcement in metal, then it is known as a whisker metal mattress composite with reinforced with whisker, and particle means this nano metal mattress composite or micro metal mattress composite. So these are the basic classification of your composite material. So fiber, you can see that the fiber or matrix which is used like carbon fiber or aramide fiber, epoxy glass fiber, these are the basic properties of each type of the fiber. But these are the some metals. So aramide and other things, you can see the specific stiffness is very more in these three, aramide or epoxy glass. But these are the natural fibers. So our aim is to use the more amount of the natural fiber so that we can make the biocomposite material. But the property wise, they are not that much good as these fibers will be good. So like coconut we are using. So we can make the hybrid. We can mix the hybrid fiber in that particular matrix. So matrix is either we are using the polymer, metal, or ceramics. So these are the different. This borosilicate glass, that is a ceramic matrix. Aluminium, magnesium, titanium. These are called a metal matrix, and epoxy, polyester, PEEK, polycarbonate, polyurethane rubber. These are called a your polymer mattress composite. So this is the Young modulus and things. So when we talk about the metal or ceramics, the Young modulus mechanical property is very good, and the other properties is also very good. But in case of the thermal expansibility, you can see that the polymer behaves very good in nature. So how we can get that property similar to the metal? So we can add some fillers in the epoxy or polymer to improve and achieve at least the property of metal or ceramics. So that's why this fiber we can add. Here you can see this carbon fiber, the stiffness strength which gives the more. So if we can add carbon fiber in epoxy, then your material strength or mechanical property is similar to your metal property. So in this way, we are playing in the composite material. So matrix we can use, and carbon. So you can see that the carbon fiber, carbon reinforcement fiber composite, it is widely used in manufacturing of structure of aerospace because of these properties good. So metal is not that much used. Metal is used, metal mattress composite in brake material or in high speed cars and landing gears. We are prepared by the metal mattress composite. So these are the various properties of the matrix and various properties of the fibers. So what are the desired characteristics required in the matrix? It is according to the mechanical and thermal. It should be high strength, high elastic elongation, high shear strength, high modulus, low thermal conductivity. So these are the mechanical and thermal properties. Chemical properties like good to bond to the fiber, low moisture absorption. Processing characteristics like good flow characteristic, rapid cure or solidification, it is required. Low shrinkage during and after molding, because at the solidification time the shrinkage occurs. So we just provide the shrinkage allowance. Other factor like we are it should be low cost, easily available, low dielectric constant, and it should be low density. So these are the required or important properties when you decide the matrix, which matrix you will be used. So this is the basic graph till now, uh, how the material is developed from the ancient days to present era. So 10,000 VC, you can see only we have the gold, or in case of metal, or polymer is only wood or skin fiber, and composite is only straw bricks. So in that era, we also make the bricks of the mud, from the mud, and stone is there in the case of the ceramics. So further, when we moved into the VC to DC, we developed some ceramics like flint, pottery, glass. So in that, when we move from VC to DC, this ceramics is evaluating more.
It's 12
But in
o'clock.
case of metal, only gold, copper, bronze, and iron is developed. But polymer, only wood is there. So we are using these materials in that particular case. But in case of composite, we developed, at least in DC, the paper. Paper is developed. Paper was developed in that particular era. Further, when we moved from the 1000 DC or 1500 DC, then we can see that the further we have developed the cement, and we developed the glue. So easily we can make the structure very heavy fort and very reliable fort. We can easily make it. When we move further, then refractory material can become Portland cement and fused silica, and in case of polymer, bakelite, thermoplastics. But in case of metal, cast iron, steel, alloy steel, light alloy, up till 1960. We also developed the titanium and zirconium alloy. So as the metal developed, polymer is also developed, ceramic is also developed. So, but the composite was not used in that 1960. After 1960, when we move into 1980, we just make the composite material, that is glass fiber reinforcement composite, CFRP, AFRP. So different types of the composite. And in this era, we just use in the composite material, improve the composite material in the aviation industry. So after this 1970, we are targeting to use the composite material more. So this is the evaluation, and in this polymer also we have developed the different types of the polymer, and nowadays we are talking about in polymer conducting polymer, because previous polymer was non-conducting. Nowadays we are talking about the polymer conducting polymers, or self-healing properties of the polymer. So these are the called a smart material, high temperature polymer, because polymer always the very low temperature, high modulus polymer. So how we can get these type of the polymers, or development of these polymers, and these polymers we can use in that in making of the composite material or further application. So metals case, nowadays we are talking about the aluminum, lithium alloy, dual phase steel, microalloyed steel, or new superalloy like Highness 16, Highness 25. These are the different types of the new superalloys, apart from the Inconel 718 or other materials. So in metal case, nowadays we are talking about high entropy alloys, also one alloy which is used in the nuclear power plant. So these are the different development till now from this 1000 BC to 2020 BC. So that pictures is very clear to understand the development of the materials. So again, we back to the future. So these are the mud bricks, straw bricks, which we are using that to develop the structure. So Egypt, or Egyptian was very intelligent at that time. So they just made the bricks and other things. So that's why they Egypt used the in Mesopotamia in 3000 BC. They just used the composite bricks. So building of in durable building, ancient Greece. In Greece, what they did on 1100 BC, they just make the seal from the metal. So in the war and something, they can use this type of the seal to stop the means whatever hammering of your sword and other things. So that shield is used. So Greece or Rome is developed shield in first time in 1100 BC. They just use the different gold. We mix the gold with bronze, whatever the material. You can see here we have gold, bronze, iron, and copper up till this development. So because of that reason, Greece thus develops the steel. So these are also like due to this emission of CO2 or NOx, we need to close to zero biocomposed or fully morphing and joining the structure by adhesives. So these are the things still that time after development of the glue in polymer, the people are using that type of the structure. So light structure design philosophy comes like a light structure is a matter of design, not a matter of weight. So that if you can design properly, then your structure can be also proper. How you can reduce the design? How can you proper design so that your specific young modulus, specific yield strength, specific tensile strength will be more? And also for the ductility and fatigue behavior is also essential concern when you design any structure. So light structure, don't think about that we can only reduce the weight of the material, but it is basically focus on the design aspect. If you can properly design it, then it will be more lighter weight. Like for example, I can say in real life nowadays, you can purchase the phone, the same size of the phone of Android or some Redmi phone or Apple iPhone. The weight is very lighter in Apple iPhone, but rather than the other phones. Why? Because they have designed the material or designed the structure in such a way that it is very light. But so that's why this line is very important. Don't think that lighter structure means you can reduce the weight. We can't reduce the material or something. We just design in such a way that so it can gives you the light structure. So design engineering is very important, or design engineer is very important in any aspect. So when we talk about the forces on the airplane, then lift, thrust, weight, or this. So this lift can lift the airplane, and drag gives you the forward motion of this particular plane. So these are the four forces which is very important in airplane. And when we design the material, we just take into the account these four forces. And this is the airframe structure requirement, how we can go in such a way that these things will be like wing bottom is under compression and wing top is under tension. So when we design the things, we can check through the finite element method, like how much is the tension, where is the stress concentration is more, and other things when we design. So these are the different types of the stresses which can develop in the airframe. So this is called the impact, because whatever it comes, it is nose. And here in this stabilizer or this tail, torsional force is there. And here bending force is very important because they can move. Corrosion resistance in this here. These are body is going to the compression, so compressive forces. Shear stress, because these maybe shear because this attach with the wings, attach with the body. Hoop stresses develops in the cylinder. So in strength of material, I think you have studied about the hoop stress, thin and thick cylinder. That is very important. Hoop stress, how you can design the T by D ratio. That in that way you can control the hoop stress, thickness and diameter, and compression. So these are the different types of the stresses which is very important in aircraft structure design. And it is not a one day job. It is a continuous job. You can continuously improve the design so that hoop stress will be less, other shear stress will be less, compressive force will be less, corrosion resistance improve, bending force, torsional force. So because of that reason, you will study the strength of material. So torsional moment Ty(J) is equal to G theta by R, the bending equation. We can. That's why those topics is very important in mechanical engineering. So these are the current status of this aircraft structural material. Like we are using also the magnesium. Include the magnesium. Magnesium is apart from aluminum. Magnesium is also very important. So AZ31, AZ61, AZ99. These are the different composition of magnesium in that particular aluminum with zinc. Then these material is also used to develop the brake composite also. Titanium based alloy, in nickel based alloy, pneumonic material, it is also used in structural applications. Then composite material. So these are the property like carbon fiber, CFRP. You can see that ultimate tensile strength, Young modulus, density. So this CFRP is more or less same as our metal, Young modulus. So because of that reason, CFRP is widely used. After that, Kevlar fiber and boron fiber reinforcement in aluminum. So that is also very huge. So nowadays, this aluminum metal matrix composite is also used in this composite. Is that's why the 70 to 80% composite is our target to reduce the weight and improve the other efficiency of the aircraft. So when we comparison between the metal and composite material, specific properties like density, specific and modulus, specific strength, then we can find that the composite gives you the more good property like Kevlar fiber, carbon fiber. It is more specific strength like 915 megapascal for this. And in terms of this Young modulus also, it composite gives much better result as comparison to the metal. And metal, it is very not easy. Advantage is it is having the complex shape, high strength to weight ratio, tailored. In composite material, you can tailor the mechanical property, corrosion resistance, impact resistance, design flexibility, fatigue resistance. But metal is cost effective. It is very costly because we won't need damage resistance, conductivity, easy to fabricate. So drawbacks is here heavy structure. Metal is heavy structure, which is not good for aircraft. Want to corrosion damage because metal can be damaged in humidity, corrosion resistance, and also inferior to creep resistance. But composite gives you these all properties. But composite is unpredictable. You can't say that it will be 100% perfect. They are brittle in nature, and if you are using the thermosets plastics, then recyclability is very not that much good because thermosets is not recyclable. So proper selection of the matrix is very important. Like thermosets or thermoplastics, like thermosets is properly cross-linked. Thermoplastics, when you provide the heat, they can again it can regain its reshape. So cross-linking, and then further it will remove the cross-linking. So that is the basic difference between these two type of the material which are widely used in fabrication of the polymer matrix composite. But thermosets are having the more thermal stability as comparison to the thermoplastics. But problem in this case, thermosets, it can be recycled, but it can be recycled, thermoplastics. So novel manufacturing techniques, it is very important to make the panel of the structure. So this you can see the picture of the fuselage panel, which is manufactured by the novel manufacturing techniques like pin forming process, this advanced metal forming process. So you have a seat. So pin forming process, either superplastic forming process, explosive forming, electromagnetic forming, electrohydraulic forming. So we can form the seat structure. So these advanced or modern manufacturing techniques is very important in case of the manufacturing of aircraft. Like this type of helicopter cannot made by the thermoplastic. So we can how we can make this we can make by the uh, forming process. So there are different types of the advanced composite manufacturing techniques like autoclave, resin transfer mold process, performing process, preforming process. So these are the various uh, processes, composite processes which we use to manufacture the composite material or composite structure. And also we are targeting the future aeronautical material like a smart material which is easily means healed, so self-healing composite material, so that they are using some types of bubbles, and when some cracks will be initiated, then those cracks, due to those cracks, these bubbles, whatever the reinforcement or matrix it will be there, they can burst and they can fill the material itself. So that is called a self-healing material. So these are called a multifunctional material. So these type of the material is also we need to use in the aeronautical material, but still the research is going on. So advanced composite material like graphene is also adding in the particulate to improve the young modulus and tensile strength of the composite material. So you can see graphene is having the C type of the structure, and easily like this type, if you have the seat, whatever the graphene seat, you can see that easily hold the huge weight. So that is the just example of the property. So this is a graphene so strong then they can hold an elephant also. So that because of that reason we are using the graphene in that carbon reinforcement fiber. So carbon is this graphene is nothing but it's the structure of the carbon. So carbon fillers is graphene, graphite, multi-wall carbon nanotube, single wall carbon nanotube. So these are the carbon structure. So graphene is more stronger than other things. So we are mixing the graphene inside to improve the property. Another carbon nanotube, I told you, these are the some cylindrical structures, so they can create some rolling friction. So sliding friction is more than the rolling friction, so they create the rolling friction, though you can also reduce the friction. So these are the further advancement in the composite material. You can add the carbon nanotubes, graphene to improve the property. Self-healing properties, that is another. I already told you that structure of the polymer which is susceptible and from the crack, and these cracks can be propagated. So these are catalyst and microcapsules which are inside the material. When crack propagated, these microcapsule can be burst and they can heal the particular material, and you will get the proper bonding. So these are called as self-healing properties. As you have seen in the Hollywood movies, they just self-heal the material or self-heal the body also. So means whatever the damage will come immediately, it will be self-healed. So problem to be solved, like to take the advantage of the improved property of the multifunctional material, they need to access the effect of additives on the mechanical behavior, possible degradation of the mechanical behavior of the material like strength or fatigue. New multifunctional material reveal the significance of the material production quality on the entire multifunctional material concept affects directly the degree of internal defects. And we are also talking about the cost effectiveness. That is very, very important. When we discuss any material, any manufacturing process, we also work on the cost. So that is very important, reduction in the cost. So how you can properly design the material, design and use the material effectively, then you can reduce the cost. Means if you can minimize the wastage, you can reduce the cost. If you can proper assembly the lines, then also you can reduce the cost. So that's why in industrial engineering we also studied about the line balancing, how the material will flow from one station to the another station. That line should be properly balanced, and it can reduce the time, work study or time study that you have studied in industrial engineering, work study, motion study. So because of that reason, so nowadays nanocrystalline material is also used. So it is a metallic alloys with grain dimension of 100 nanometer or less. So these are called a nanocrystalline material, which gives also the very good property in the composite material. So, but the problem is about the nanocrystalline material can make the brittle nature. So we can work on this ductility and fatigue aspects of the nanocrystalline material. So we can work on the thermodynamic mechanism, kinetic mechanism. So, but the advantage of the nanocrystalline is significant material, like it gives the more mechanical property, greater mechanical property as comparison to the metal at ambient temperature. Ambient temperature means 25 to 30 degrees centigrade. So we just add the nanocrystalline material to fabricate the aluminum alloy, like high entropy alloy. You have word high entropy alloy, where the we use to improve the temperature property and other property by mixing the nanocrystalline material. So these you can use in the nuclear reactor and other space industries. So alloy is very, very important. These are various form addition in which either you have add the nanocrystalline material in nickel or titanium. According to that, your property will be required. So future of aeronautics is, you can see, this is the future of aeronautics. This is the future of aeronautics. This is the NASA plane in space. This is the another feature of your Mohar. Please mute yourself, unmute yourself. Sorry, mute. So in the inside the sea also you can make the tunnel. That tunnel can be corrosive resistance and other properties of good, so you can move from one position to another position. So this is the future aeronautics. You can use the monorail in that plane and other things. So this future airports up till 2050, we are thinking international aviation industries are thinking like that. And application of the composite material is very wide. In the ship industry, we are making the ship in different layers of the composites according to the applications. In boats also we are using the composite to reduce the weight. In sports equipment also we are using, like if you can purchase the Yonex badminton, then it will be very lighter weight as comparison to the common one. So they all are used the composite. These are the graphite composite. We are just using the carbon filler. Other things is also very composite. So lightweight of this handle. So these are the sports equipment we are using the composite, and it is very flexible also. In future, cars body is also made up by the composite like Rolls Royce or something, but the cost of those cars is very high. So it is not easily purchased by the some common person. So this in automobile also widely used composite bodies to improve the structure, improve the fuel efficiency. So those type of the cars is very costlier. Another in power generation also, when we talk about this wind turbine, its turbine blades can be having the more impact of the wind. So we can improve the fatigue strength, impact strength. So we can use the composite material and design of these wind turbine blades. Further building and structure also we can use to composite material in this like seashore structure. You can make this composite material so that it will not corrode it, and these are called used in the petroleum industries. The structure you can see this homemade composite structure you can make in near seashore area where the more earthquake, more flood is there. So this temporary structure is very beautiful structure you can make and you can sit. So like in European countries, we are using mostly composite material. Home also. Bridge also we can make by the composite material. This honeycomb structure you can see, which is more. So in this case, you can reduce the material to construct the bridge, but it can sustain the more load as comparison to the previous bridges. So these composite material is widely used in bridge applications also. So this is the basic introduction about the different material used in the aerospace industry, and there are various applications of the composite material in various fields. So thank you very much. And these are my books which I already published in that era. And this is the modern manufacturing technology. It will come in market. In this, I have covered mostly all modern manufacturing technologies in present scenario, which is used in the industry. So thank you very much. Any questions, then you can ask.